Hello again. This is Mr. Wilson. This is physics video review number 5, and I'm going to call this Projectiles 2 because I didn't get to Duke's projectiles, which I'm going to do right now. And I apologize for some of the other runs because I didn't have the equation low enough, and the one equation I focused on most of the time was the D equation. D equals VIT plus 1/2 AT squared, the fourth equation on your reference tables. So sorry I got that cut off, but that's what that is. This is a Duke's projectile. Remember we talked about cliff projectiles last time, where the baby went off the cliff into its mother's loving arms. This is the Duke's projectiles, like Bo and Luke Duke. When I was a kid, I used to watch Dukes of Hazzard, the original Dukes of Hazzard, not the cheesy movie. It was a cheesy TV show. And so when in Hazard County, they were driving along, and all of a sudden they get to a bridge that was out. Roscoe P. Coltrane, the sheriff, was chasing them. And they'd go, and always there was this big pile of dirt in the shape of a ramp where the boys in their General Lee would go off the ramp, over the bridge, in a Duke's projectile. And then they would say, "Yeah!" like that, which is pretty cool. So Duke's projectile would be a projectile launched at an angle. And so there's a couple steps you need to do. If you look on your sheets, on your review packet, it says Duke's projectiles launched at an angle from the ground. Step 1 is to find VIY and VIX. Now, if you remember, it's actually launched at an angle. So this is your VI, which is your any vectors, the vector A, if you go back to like your original thing we talked about where A is in the middle, AY, and AX. Y is the vertical component, right? And X is the, I'm giving you a chance to think about it, horizontal component. Which one depends on the sign? Y sign! And then your X is your cosine. So here, specifically, we're going to talk about the horizontal velocity, VIX, and then the vertical velocity, VIY. So that's going to be the first step. We're going to find that, and I'll give you an example in just a second. Number 2 is going to be find the time. Now, if you need to find the time for a Duke's projectile, I'm going to recommend that you just remember this equation. VIY divided by gravity times 2 is the total time in the air for a Duke's. I'm going to write Duke's here. That's the only time you would ever use this equation. You take the vertical speed, divide it by gravity, because if you think about it, gravity's trying to divide it up into little chunks of 10. Every second it takes away 10. So it goes whoop, and then goes to 0. So this is the vertical speed. Whoop, boop. So the times 2 is what goes up must come down, right? And then range, which is dx. And this you're going to use the same equation that we did before, which works out to be VIX times time, because you don't have any vertical, what am I trying to say? You don't have any vertical velocity or vertical acceleration going sideways. Sideways, VIX remains the same. And that reminds me, I haven't done that little song yet. Height and range, VIX remains the same. Sing it with me. Height and range, VIX remains the same. So since VIX remains the same, it's going to keep on trucking, and you're just going to multiply by the time. This one, by the way, VIY, Y sine. So that's going to be degree mode, don't forget. And VIX is VI cosine. So, actually I'm going to stop right there, because I think if I gave you, I think I'm going to stop it with as far as information we have, because if I gave you an example, it'd be a little long. So this is how you tackle a Duke's projectile. So if I gave you, say this is 100 meters per second, and this is 30 degrees, you would then figure out the VIY and the VIX, and then whatever the VIY is, you divide it by 10 for gravity, or 9.81 if you want, multiply it by 2, and then you take your horizontal speed and multiply it by the time. And at this point, you should be able to do that. And if not,